So this is a heating curve for water showing the energy needed as 1 mole of water is heated from negative 25 Celsius up to positive 125 Celsius. And there are different line segments here that are labeled, and there are homework problems that are similar to this, and there will be probably at least one exam question as well, asking you to calculate how much energy is needed to take something from some temperature to another temperature. And the way this is going to work is there is an equation that we can use for each line segment, but we have to calculate each line separately and then add them together at the end. So this is the one that we just learned about, fusion, heat of fusion. Writing with the eraser. So there the energy is going to be based on the heat of fusion times the number of moles. This heat of fusion, kilojoules per mole. If we multiply by the number of moles of that substance, we'll get the amount of energy needed. Up here, this is the heat of vaporization. So we're vaporizing water, again, times the number of moles. Those are the new ideas, and then these others are from, this chapter 7. Remember, Q equals mc delta T. He's back. Here we have a temperature change going for the water. It's going from 0, where it has first become a liquid, up to 100, so that's our delta T. C is going to be the specific heat capacity for liquid water, and then we multiply by the mass, and that will get us the energy change there. We would also use Q equals mc delta T down here and up here. But this is going to be the specific heat capacity for water in the gas state, and this is for water in the frozen state, solid state. So we have seen that the heat capacity of ice is 2.09 joules per gram degree Celsius, and the heat of fusion of ice is 6.02 kilojoules per mole. If we take a small ice cube that's at negative 10 degrees Celsius and we put it into a cup of water at room temperature, what is going to have the bigger factor in cooling that water? Is it the ice warming from minus 10 to 0, or is it the ice melting? You can't make a real direct comparison here without doing some conversions, because this is grams and that's moles. But this is joules, 2 joules, and this is 6 kilojoules. Right? So the melting of the ice is going to play a much bigger part than the warming up of the ice. Does that make sense? Come on. There we go. Yeah. Okay, so here's an example. Calculate the amount of heat needed to take 1 mole of ice at negative 25 degrees Celsius to 125 degrees Celsius. So this is that picture that we just looked at. I'm going to mix it up a little here and say, instead of going all the way to steam at 125, let's go to water at 75 degrees Celsius. And just show you how to approach this problem. The first thing you need to do is draw an ugly picture. Okay? We want to draw the heating curve so that we can see what parts we're dealing with. So I'm going to draw a heating curve. Well, I didn't mean to make it that ugly, but whatever. So we're starting at minus 25 degrees Celsius, right? And we're going up to 75. So I'm going to label the bottom of this minus 25, and I'm going to put 75 up here. We need to know the melting and boiling points for whatever substance we're doing here. What's the melting point of water? 0? 0 Celsius. So I'm going to put 0 in here. And what's the boiling point? 100. Well, 100 is above this. This is the end of where we're going, so we're not going to actually use that part. So what's going to happen is our mole of ice will need to warm up until it gets to 0, and then it needs to melt, and then that liquid will warm up some more until it gets to 75. If we kept going up to 100, it would boil, but we're not going there. So I have 3 different lines here. So I'm going to calculate 3 values, and then I'm going to add them together. I wonder what happened in his life this morning. He must have just really had a rough morning. He's just taking it out on everyone. Okay. So for this part, I have a change in temperature. So for A, I'm going to use Q equals MC delta T. The change in temperature is 0, the final, minus the initial. 0 minus negative 25, so that is 25 degrees Celsius. I have 1 mole of water. If we do the calculation, we'll find that that's 18.02 grams of water. So 18.02 grams of water, and this is ice, right? It's below 0, so I want to use the heat capacity for ice. So 2.09. Sorry for the pause, but can't do anything. So there's many variations of this kind of a problem. You can do it with other substances that are going to have different melting points, different heat capacities. You can, start at a solid and go to a gas. I mean, there's so many different ways you could do it. And the other thing you can do is you can say, well, how much energy is released if I take water at 75 degrees and I freeze it and bring it down to minus 25? If you have a question like that where you're going in the opposite direction, I think it's less confusing to first solve the going forward and then recognize if I'm going backwards, I just change the sign. It's just going to be negative. That'll avoid some issues that you might have with negative signs. Any questions?